Hello and welcome to Essential Math Skills for Science, and in this video we're looking at drawing scatter graphs. So in the previous video we looked at different sorts of graphs, bar charts, line graphs. In another video we'll look at pie charts, but in this one we're looking at what are called scatter graphs. Let's have a look at what a scatter graph actually is. So it's like a line graph. It says there, a scatter graph is like a line graph, but you don't get to join all the points together. Now scatter graphs are really great to show two variables or two sets of data and how they relate to each other. For example, you may be doing an experiment to find out how temperature affects the rate at which magnesium dissolves in acid. So here we've got temperature 20, 25, 30, 35, time taken 36 seconds, 27 seconds and so on. Okay? If we now look at the data plot, this is what we've got. Now scatter graph, okay, we're not joining all the points. Notice the points are not being joined together. What we're doing is drawing what's called a line of best fit. It says here, with a scatter graph it's then possible to draw a line of best fit to show how the two variables relate to each other. Right, let's have a go at our own data, shall we? Now here's a data set. Now, here we've got electrical circuit, and in the electrical circuit we're setting the current in amps from 1 up to, there we go, 10 amps. So we probably use something like a variable resistor to set the current at those levels. And having set those current levels, we're then recording the voltage. So the voltage, you can see here it's 1.1 at 1, 1.9 at 2, 3.1 at 3, and so on. Now, the current, because we are changing the current, that's what we are control of, we call that the independent variable. It's what is changing, and it always goes along the x-axis. The voltage is what we're going to measure using a voltmeter, and because it's what we measure we call it a dependent variable. It's what we're measuring, the voltage, and that goes along the y-axis. Let's look now at the axes of the graph. So as we said, on the x-axis we've got current, on the y-axis we've got voltage, and notice we've got the units, volts and amps. Don't forget to always include units on the axes. And here's the data we want to start plotting, 0 to 10 for current and 0 to 10 for voltage. Spread the axes to use as much of the variable space as you possibly can. Let's start putting in the data points. Now I did suggest in a previous video that you actually use very light pencil lines so you can see where they're going. So 1 amp is 1.1 volts, 2 amps is 1.9 volts, 3 amps is 3.1 volts, and so on. And you can then continue and plot the points. You end up with a graph looking like this. Okay, there's our complete scatter data there. Now notice we haven't joined the points together. What we're going to do is actually draw a line of best fit. Now line of best fit, okay, doesn't need to go through all the points. In fact, some of them are on the line, like that one there, but others are off the line. All the line needs to do is to pass to as close as many of the points as possible, and that's what's called a line of best fit on a scatter graph. Now sometimes, and I've done this deliberately here, we get a point that actually is well off the other data points. So sometimes a point doesn't fit the pattern. Now what we call this is an anomalous result, and when we're drawing a line of best fit we completely ignore it. We're not interested. It's anomalous. Bye bye. Now line of best fit, okay, on the previous one we saw it went that way. This one is going that way, so it can be a straight line, or it can be curved. It could go that way, or it could go that way. Okay, different sorts of lines of best fit depending on the data you're using. So don't be afraid to use a curved line as well as a straight one. Now let's think about some data for you. It's your turn. An experiment was carried out to investigate how temperature affects the rate of reaction. Results are shown below. Plot a scatter graph at these results, then draw a line of best fit. Pretty simple data, easy to plot. Have a go. Second set of data to have a go at. This is all about photosynthesis. The rate of photosynthesis can be measured by recording how many bubbles of oxygen gas are produced by a plant in a given time. So here we've got two of the measures, distance from plant in centimetres and bubbles per minute. Now in an experiment to investigate how light intensity affects photosynthesis, a lamp was moved progressively away from a plant. You can see here it starts at 0 and it's moved progressively away to the plant until it ends up 100 centimeters away from the plant. And look how the bubbles change. 122 there, 10 there. Okay. Now plot a scatter graph of these results and draw a line of best fit, and from this, what can you conclude? Aha. So that's the end of this video. Thanks for watching and listening, and I'll be back with another video very, very soon. So bye bye for now.